Alright, agents, and welcome back to Spy School. This is an urgent briefing. A critical asset, the Master Engineer badge, has been locked away in a high-security vault. Your mission, should you choose to accept it, is Mission 3, the Vault. We've detected a security breach, and the alarms are blaring. This means we have a very limited window to get inside, retrieve the badge, and get out before the system reboots. The blueprints are on your desk, but they're a mess. We need you to assemble a portable vault cracking device using only standard tissue field equipment. The fate of this operation rests on your shoulders. Stay sharp, stay focused, and let's get to work. Before we build our device, we need to test your reflexes. Every good spy needs to have a razor-sharp eye for detail. On your screen now is a highly detailed image of the vault's antechamber. Hidden somewhere within this room is a secret numerical code. You will have exactly 10 seconds to find it. This is your spy reflex test. The clock is ticking. Agents, look closely. Scan every corner, every object, every shadow. Is it on the bookshelf, under the table, behind the curtain? The pressure is on. 5 seconds left. 4, 3, 2, 1. Time's up. Did you find it? Let's see. There it is, tucked away on the side of that vase. If you spotted it, congratulations, you've passed the first test. Your observation skills are top-notch. If you missed it, don't worry, that's what training is for. We'll make a master spy out of you yet. Now that your eyes are warmed up, let's gear up for the main event, building our vault cracker. To construct your vault cracking device, you'll need the following standard tissue spy gear. First, the containment unit, also known as a simple cardboard box. This will form the main body of our vault. Next, you'll need a graphite infiltration rod, which you might know as a pencil. This will serve as the central axle for our locking mechanism. Finally, you'll need a roll of high adhesion filament, or as civilians call it, tape. This will be crucial for securing the components. Remember these 3 items: the box, the pencil, and the tape. These simple tools, when combined with your spy ingenuity, will become a sophisticated piece of engineering capable of bypassing even the most complex security systems. Let's gather our materials and prepare for the construction phase. Alright, agents, it's time to build. Let's take our containment unit, the cardboard box. First, on the top of the box, you're going to carefully cut a small hole right in the center, just big enough for your pencil to fit through. This is where our central mechanism will pivot. Next, take one of the side flaps of the box and cut it off. This flap is going to become our vault door. Now, reattach this door to the box using a piece of tape as a hinge. Make sure it can swing open and closed smoothly. This is your access point. Now for the lock. On the inside of the box, right next to the edge of your new door, cut a small notch. This is the secret to our lock. It's the catch that will hold the door shut. Now take your graphite infiltration rod, the pencil, and push it through the hole you made in the top of the box. Let it hang down on the inside. The trick is to position it so that when you turn the pencil from the outside, the tip of the pencil on the inside can slide into that little notch you cut. When the pencil tip is in the notch, the door is locked. It can't be opened. But when you rotate the pencil, the tip moves out of the notch, and voila, the door is free to swing open. Let's make this look like a real vault. Take a piece of scrap cardboard and cut it into a circle. This will be our combination dial. Tape this dial to the top of the pencil on the outside of the box. Now, when you turn the dial, the pencil inside turns with it, locking and unlocking your vault door. Test it out. Turn the dial one way to lock it, and turn it the other way to unlock it. You've just engineered a functional locking mechanism from scratch. Excellent work, agent. Now for a quick history and science lesson. The device you just built is a simplified version of a pin tumbler lock, a mechanism that has been around for centuries. The concept of using pins or rods to block a mechanism dates back to ancient Egypt over 4,000 years ago. Their locks used wooden pins that dropped into holes to secure a bolt. The modern pin tumbler lock, which is used in most doors today, was patented in the 1860s by Linus Yale Jr. The science behind it is all about mechanical obstruction. Your pencil acts as a single, large pin. The notch you cut is the shear line. When the pencil is in the notch, it physically blocks the door from moving past it. By rotating the pencil, you move the obstruction out of the way, allowing the door to open. Real locks have multiple pins of different lengths that must all be aligned perfectly at the shear line by the correct key. What you've built is a brilliant example of simple machines and mechanical engineering in action. It proves that even the most complex-looking problems can often be solved with simple, clever principles. And that, agents, is a lesson every spy must learn. This isn't just a craft, it's applied science. Agent, you have successfully completed your mission. You analyzed the situation, passed the reflex test, and engineered a solution under pressure. You built a device that demonstrates a core principle of security engineering, and in doing so, you have successfully cracked the vault. The high-value asset has been secured. For your outstanding ingenuity, your resourcefulness, and your brilliant execution of this mission, you are hereby awarded the Master Engineer Badge. Wear it with pride. You have proven yourself to be among the best of the best. Congratulations on a job well done. Your skills are a credit to this agency. Until the next mission, stay vigilant. This is Spy Command, over and out. Thanks for joining the mission, and be sure to subscribe for your next assignment.